Section 3.1a is about writing equations. We're going to get some background out of the way by looking at a couple things here. When writing equations, we use variables to represent unspecified numbers. So one of the things that we're going to do when we write equations is we're going to look at the variables that we use. These two words here, verbal and algebraic, you've seen those before. Verbal means in words, and algebraic means variables, numbers, and symbols. These are two different ways to write equations, in words or using the symbols. And then finally, the word is often used to represent equality. A lot of times you'll see the word is in some of these equations, and that's going to mean you're going to set things equal. Here it says translate each sentence into an equation. So our sentence says a number b divided by 3 is equal to 6 less than c. Well, I want to start here with this is equal to. That means we're going to have an equal sign, and that's going to divide our equation in half, so we'll work on the left and then we'll work on the right. Well, the left side of the equal sign says a number b divided by 3. We could write this as b divided by 3, but typically I like to do division as a fraction. I think it's going to be a little bit easier when we solve. And then the second half, 6 less than c. This less than is kind of important. A lot of people think less than means to just write 6 minus c. But if you think about it, if you're 6 less than, that means you're 6 smaller than c. So you're going to start with the c, and then you're going to take the 6 off of that. So 6 less than c would mean 6 minus c. So this would be our equation written out in algebraic form. Second one, 15 more than z times 6 is y times 2 minus 11. Well, here's is again, so that'll represent equals. So on the left, we're going to go 15 more than z, which means we're going to start with z, and then we're going to add 15 to that to be more than. And then on the right side, y times 2 minus 11. Well, even though it says y times 2, we typically write that as 2y, because we always write the number in front of the letter when we multiply, and then minus 11. Here I'm going to show you something called the 4-step problem-solving plan. This is a plan that most people use when they typically are faced with some sort of a problem, either a math problem or some other problem in life. You just don't realize that you do these 4 steps. The first thing when you have a problem of some sort is you explore the problem. You try to understand the problem. In math, we want to find out what information is given, and a lot of people don't spend enough time on that problem, or what you're asked to find. Those are 2 really important steps. When you first encounter a problem, you want to find out what are you given in the problem and what is the problem asking you to do. A lot of people don't spend enough time on that step, and it makes the next step hard. Step 2 is plan a solution. Come up with a way that you're going to solve it. Well, in algebra, we definitely have to focus on this idea of a variable, and that's what we're going to focus on especially today. You have to define a variable. You have to pick what variable you're going to use to represent something that you don't know, and then you're going to have to solve for that variable. That's fairly typical for a problem in algebra. Step 3 is solve the problem using whatever plan you developed in step 2, and then step number 4 is checking the problem, examining the solution. Does it make sense? Given the information, did you answer the question? So these 4 steps make up the 4-step problem-solving plan. Here's an example problem for us to solve. A popular jelly bean manufacturer produces 1,250,000 jelly beans per hour. How many hours does it take them to produce 10 million jelly beans? Well, I want to examine this idea of 1,250,000 jelly beans per hour. If it takes 1 hour to make that many jelly beans, think about how many it would take, or how many jelly beans it would make in 2 hours. Well, you just take this number and you do it twice. You'd multiply it by 2, which is why this word per is interesting. When you see per, a lot of times it's going to mean multiply. So if I have 1 hour, I multiply 1 times this number of jelly beans. If I have 2 hours, I multiply 2 times this many jelly beans to show how many I'm going to make in that time. Now my question says, how many hours does it take to produce 10 million jelly beans? So what's the unknown? What's the thing that I don't know? And the answer is hours. So I'm going to say that H equals the number of hours. This is part of our problem solving plan. We have to define a variable, and I've defined the variable h. Now, how many hours does it take to produce 10 million jelly beans? So I'm going to end up getting equal to 10 million. So I'm building my equation here. And I don't know how many hours, but I know that I can make 1,250,000 jelly beans per hour, so times the number of hours. And then I want to know how many hours it would take to get 10 million. So here's my equation that I set up. Now, to solve this equation, when you're multiplying a number times a variable, you can eliminate that by using the opposite operation. So I'm going to divide by 1,250,000. When you divide big numbers like this, you can cross off zeros. You can cross off 1 0 for each decimal place, and really this is 10,000 divided by 1,250, which if you work that out, you'd find out it was 8. So h equals 8, and I'm going to label this hours so that we know we're talking about 8 hours is how long it would take me to make 10 million jelly beans. Here we're going to talk about formulas. A formula is an equation that states a rule for a relationship between certain quantities. A pretty famous formula that you may have heard of is the formula for area. Area equals length times width. And that's a formula. It states the relationship between the area of a rectangle and the length and the width of the rectangle or the square. We're going to take an example here of a formula, and we're going to translate it into an algebraic expression when we see it in words. It says the perimeter of a rectangle equals, now I'm going to stop right there and I'm going to use an equal sign, because I know that equals means equals. So a perimeter of a rectangle equals 2 times the length plus 2 times the width. Well, perimeter of a rectangle. I don't know anything about that, so I'm going to use the letter P. And then it equals 2 times the length. Well, I know what 2 times means. It means 2 times something. And length, I'm going to use the letter L because we don't know what it is. I could write that with a dot or parentheses, but typically 2L is fine. Plus 2 times the width. I don't know the width, so I put a W. So this is how we can create the formula for the perimeter of a rectangle by turning the words into algebraic symbols. In our second example, we talk about perimeter again, so I'm going to use a P to represent perimeter. This time the perimeter of a square equals 4 times the length, so 4 times L, the length of the side of the square. So there we go, 4 times L. I've seen 4S be the formula also, S meaning the side of a square. Some people use L for length. It really doesn't matter what letter you use. Some letters are more prevalent than others, but the point is we were able to convert this verbal sentence into an algebraic expression or a formula. Now we're just going to have some more problems for you to practice translating into equations. Please feel free to pause the video and try them, and then look back at the solution. Here, 2 times the number t decreased by 8 equals 70. Well, equals 70 is probably the easiest part of that. So we're going to focus now on 2 times a number t decreased. Decreased means subtraction. Decreased by what? Decreased by 8. So subtracting 8. And then 2 times the number t looks like that. Second one, 5 times the sum of m and n is the same. Is the same. There's that word is again. That's my equals, is the same as 7 times n. That seems pretty easy to me, 7n. Now I want to look at this. 5 times the sum. Remember, back in chapter 1, we looked at this word, the sum, and the sum means you want to look for the and. The and tells you where the plus sign is going to go because sum means plus. So this says the sum of m and n. Now what are we doing with that? We're multiplying it by 5 because it says 5 times the sum. Now to show that, we use parentheses so that it's not just 5 times n or 5 times m, but it's 5 times the whole sum of that. 2 more here. This time they're going to be formulas. It says the area A of a triangle equals, there's the equals. Now what equals? The area, so this is going to be A equals 1/2 times the base. So 1/2 looks like that, times, we'll just put a B next to it, times the height. So this is actually the formula for the area of a triangle, 1/2 base times height. You may have also learned that in grade school as base times height over 2. Here the circumference C of a circle equals circumference C, the product means multiply, of 2 So we're going to multiply 2 times pi and the radius r. So circumference equals 2 times pi r.